Good morning, students. This video is for class 6 science, and today we will continue with physics, that is electricity and magnetism. In the last class, I have already explained you all the characteristic, the properties of magnet. Today we will discuss about the magnetic field of a magnet. Magnetic field of a magnet. The region around a magnet within which a magnetic substance experiences the force of attraction or repulsion is known as its magnetic field. So all of you must have seen a magnet, and if you have bought near any iron object or any object which gets attracted by magnet, you will see that whenever you bring closer to the magnet, it automatically gets attracted. Or sometimes, or any object which repels when you bring near the magnet, when you bring closer to the magnet, it will repel. That means it will move away. So the area within which the magnetic force acts, behaves, that region is known as magnetic field. So if you consider this as magnet, and if within the limit of its boundary, it acts as a magnet, that means it pulls. Whenever the area, suppose if you take this as a magnet, suppose, so it has an area within which it will behave. It can attract as well as it can repel. So that region, that area is known as the magnetic field. Beyond this, the magnet is not going to behave as a magnet. It will have no power to attract or repel. So this region till which they can behave, they can attract or repel, is known as magnetic field. The magnetic field is represented by some imaginary lines which are called as magnetic field lines. So this imaginary line that comes out from the magnet, they are known as magnetic field lines. These magnetic field lines are curved lines considered to originate from North Pole and end at the South Pole. So these curved lines, so if you say, so if you take this, so if you take this as a magnet, so magnetic fields are the imaginary lines that originate from North Pole and ends in the South Pole. So it starts from the North Pole and ends in the South Pole. The magnetic field lines passing through a closed surface like a coil are known as a magnetic flux, and the change in magnetic field lines per unit area is known as flux density. So if within the closed surface, if the magnetic force changes, that is known as magnetic flux, and the strength of the magnet in the flux is known as flux density. That is the strength, how much power it has to attract towards itself. The magnetic field lines also represent the strength of magnetic attraction or repulsion. So this magnetic fields line tells you that how strong the magnetic force of attraction or magnetic force of repulsion it is. The strength of the magnetic force of attraction and repulsion is not uniform throughout the length of the magnet. We all know that the force of attraction and repulsion is maximum towards the two ends. So this magnetic force, we know that this strength is maximum, that force of attraction and the force of repulsion is maximum at the two ends of the magnet. It is the maximum at the poles and less in the middle. In the middle, this force of attraction or repulsion is very less. So magnetic field lines are denser at the poles. So because the strength of the magnet is more at the two ends, so magnetic field line will also be more at the two ends. And in the middle, magnetic force lines are very less. the direction of magnetic field lines of a magnet. So after that they have given you an activity to explain this, to observe the magnetic field lines. And then in the next page, the direction of magnetic field lines of a magnet can also be understood by noting the deflection of the magnetic compass, to be explained later in the chapter. So deflection is the change in the magnetic compass. This tells you that the strength, this direction of magnetic, like which side the magnetic force moves in. So the direction of the magnetic field lines tells you which side the magnetic force moves, and it is explained by the moving of the magnetic compass. Since the compass has a tiny magnet, it gets deflected in the vicinity of another magnet. So let us perform an activity to draw the magnetic field lines of a bar. So after that they have given you an activity, and because the magnet, what they have said in the second last line is that because the magnet present in the magnetic compass is very small, that gets deflected by the attraction of another magnet. Next is the properties of magnetic field lines. So what are the properties of this magnetic field lines? Magnetic field lines are continuous closed curve originating from the north pole and converging at the south pole of a bar magnet. So if you take a bar magnet that has north pole and south pole, so it starts from the north pole. The magnetic lines start from the north pole and ends in the south pole. Within a bar magnet, the field lines move from the south pole to the north pole, and within the bar magnet, that so this magnetic field lines, they move from the south pole to the north pole. No new field lines intersect each other. No two magnets. So if you see the magnetic lines, they do not intersect. That means they do not cross each other. So the three properties of magnetic fields are: they originate from north pole and ends in the south pole. They move from south pole to north pole again, and then the last is that two magnetic lines will never intersect each other, never cut each other. So I hope all of you have understood this, children. So for today, let us keep it till here. In the next class, we will start with the Earth as a magnet. Why do Earth behave as a magnet? So for today, up to this much. Thank you, class.